I'm finally back, and I have split screen and tile management and stuff now. And like all these move independently as you'd expect in split screen mode, even though we don't really have any players yet or sprites yet. So how does all that work? Well, to begin with, there's several modes because I rewrote things a lot of times. That's part of why this has taken so long. Because I have thought and rewritten and changed and fiddled with stuff a lot. And I initially wrote the tile manager and then realized that actually for the stuff that I want to do with split screen modes and things, I want something more like a scroll manager, and then realized that I don't want to base it on the tile manager, but on some of its components and blah, blah, blah. A lot of rewrites, and my code is not a state where it works well enough to be shown, I think. So, and someone explained piece by piece. So we're starting with a tile manager, and that mode is going to look a lot more familiar. It looks like this. We have the sprite like before. We have the tiles that scroll. And so let's see how that's changed since then. Well, initially the code starts the same, the common stuff, and then we switch into that mode. And it still looks the same until we get here, where we have a tile manager. What is that? Well, it's a thing that manages all of our tile maps and tile sets and handles all of that messy business for us, as you'll see. But more, what does that contain? Well, let me grab my list of structs here, which is much more convenient than jumping between a million files, so I've prepared this for the video. Well, it has an RHDL context because it has to deal with tile sets and tile maps and allocate textures for those, and it deals with vertex buffer stuff, and it deals with the shaders, and it renders things, so it needs RGL for almost everything it does. So it gets all the reference to the context, so I have to keep passing that into every single function we call. And it has a tile view, which is one of these, which is just, we have a vector of tile sets and a vector of tile maps, and the tile sets are bind to RC pointers, just so if you delete one and it's still being used by tile map, it doesn't actually go away until that tile map goes away, just as a memory safety thing. And we have render params, which is just the render parameters for the internal vertex buffer in the tile manager. The internal viewport is the word I'm looking for. The internal viewport in the tile manager. And the conventional or like intuitive common sense definition of viewport is what I'm talking about. Basically, it's a portion of the window or screen output buffer, really, that we can draw independent tiles and later hopefully sprites and interface elements and things into. And it has a width, a height, a scale, and a scroll. And we have the tile shader, which is this thing, which holds the shader program, the OpenGL shader program, and the uniform locations, but not the attribute locations, you may have noticed, because I realized that the scroll manager is a little bit neater because you can have a different shader per view, or per, like, you'd use that as a sub level or a level or whatever in a game, depending on what you're doing with it. But that way different places in the game can look different potentially shader-wise. And then I realized that code is neater if I can assume that I know where the attributes are rather than having to check. So I just added the ability to RHGL to pass in a list of tuples of attribute names and locations, and it'll set those up for you when it compiles the shader. So now it does that. So we don't need to store that anymore, but we do have this thing, which is new, which brings us to the vertex data. And so we have this in the tile manager, or scroll manager as applicable, and this per tile set. And so the way that works, I realized two things basically. You may remember the tile layer I had last time that held the vertex buffer. I realized that, well, that's just a big grid of 1x1 tiles. So why should I have several of those when I can just have one that's the biggest size that I need and render the part of that I need by storing how many vertices are in a strip and how many strips I need to render? So I did exactly that. And then I realized, well, actually, why don't I just store one strip and then render it multiple times with different Y offsets? And that would map neatly to instancing if I had an OpenGL 3 mode, or when I do Vulkan for that matter. So why not just do that? So I did exactly that. And that's why we have a count and a height here, which is how many vertices are in a strip and how many strips to render. And then this one in the tile manager, we have the width, so we can check when we have a new tile set. Do we have enough tiles in the vertex buffer to fill the viewport horizontally with tiles, or do we need to allocate a bigger vertex buffer? And yeah, these are used to actually render. And the render group looks like, oh, I haven't opened that, hang on. It's actually fairly simple. It's really just for I in 0 through to blah, blah, blah dot height, or in other words, for i's between 0 and the height required to fill the viewport for the current tile set. We set the y offset to I, and we render count vertices. And that's about it. So that's our tile manager, basically. So how do we actually use that then? Well, we first set up a new tile manager, and that command takes a lot of parameters. The archdeal context, width, height, and scale should be self-explanatory, hopefully. This is a default tile size because we want to allocate some vertex buffer because we don't allow it to be unallocated, I have decided, Rust style. So we have to have a default size, and you get to specify that here. I'm specifying 32 as the default tile size because I know that's the size of the tile set I'm about to add. And that means it doesn't have to reallocate, but if it did need to, it would do that automatically. That works. I've tested that. So that's good. And then we have to specify what shaders we're using and the projection matrix. Then we want to add the tile set. So we tell the tile manager we'd like to add a tile set with this texture and this tile size. And then we want to add the tile map, which is a bit more complicated because it has a few more features. We say we'd like to add a tile map. We have to specify what tile set it uses, obviously. This is an X and Y offset. So let's say we construct a map out of several tile maps. Maybe we have like this room and then this corridor and then this other room, and they need to be offset so they go together properly instead of just stacked on top of each other. That's why we have this. So we can offset them where we want them to go. Right now we just have one, so I just leave it at 0, 0, but that's why that's there. And this is the kind of the Z equivalent to that, which tells the shader what the Z depth is of a layer, so we can control what layer gets drawn on top of what. And my plan is to put the sprite layer at exactly 1. So this is just below that, so sprites get drawn on top of the tiles. And then if you had a wall layer, you would put that above so that the walls get drawn on top of the floors, for example, or whatever the case may be, to be able to control the depth order in which different tile maps draw on top of each other. And then these are our textures, same format as before. And then we want this nice, we want the scrolling to start in the middle because that looks nicer than having it start at the corner, which is the default at 0, 0. So we set the scroll. You know, in a game you would have a player object that gets spawned in somehow, but we don't have a game yet, so we don't have a player object to follow. So we just hard-code it to start in the middle. This is just empirically, we need to move exactly 6 tiles right and 8.5 tiles up times the size of the tile in game pixels because we don't have scaling, so we want to use game pixels, not screen or window pixels. That's just hard-coded how many tiles we need to scroll to get to the middle. And then this is just the sprite stuff from before. This is just clear color blending and culling like before. This is more sprite stuff like before. This is also like before. This is just me testing the memory management by cloning the tile manager with a custom function that uses certain things to see that it all drops neatly. We're not going to use that, and it drops neatly, so let's not worry too much. And the loop is like before until here, where we want to scroll. Instead of directly setting scroll values, we tell the tile manager we'd like to scroll its internal viewport by 2 times each delta. 2 because we have scaling now, so for screen pixels is going to be, for a scale factor of 2, well, 2 times 2 is 4, so we want 2 here to get the same scroll speed as before. Then we just clear, tell the tile manager to render its stuff, render the sprite like before, and that's basically it. The rest is like before. And you may notice the only cleanup code that runs is for the sprite because all the tile stuff is inside the tile manager, which cleans all that up for us when it drops. So that's nice. And that brings us to the scroll manager, which we're still not doing split screen yet. But we don't have a scroll manager and we don't have a sprite anymore because I don't have a sprite manager yet. That's next on the to-do list. I'm working on that, but we don't for now. And that code starts with a scroll manager. So what is that? It's kind of like the sprite manager, but kind of not. Let me show you. There it is. So it has a context like the tile manager for the same reasons. It has a vertex data like the tile manager for the same reasons, except it's type parametered because there'll be another variant of this for Vulkan that we don't have yet because we don't have Vulkan. But in practice, this is the same vertex data as before. And we have viewports and views. So viewports are going to be the, sub windows, like you had 4 in split screen, but you had 1 in single player just now, that kind of thing. And this is the vector that holds those. And this is a vector that holds views, which are like different areas in the game that a viewport could show. So you could use that for sublevels or levels or what have you. And the idea is that one player can go off through a portal and end up in a different sublevel or level or area or what have you. And then you just repoint that viewport to that view and set the scrolling to wherever they're supposed to be in that view that they ended up, and then switch that back seamlessly, and you can keep several places in memory and switch between them. So that's the idea there. And that's also just a plain vector. And so the viewports, I should have mentioned, have an X and a Y. In the tile manager, those are implicitly 0 because we just have the 1. In this case, we may have several, so we specify where they're located, what their offset is from 0, 0, in addition to the render parameters as before. And the view is just a number that indexes into this vector to indicate which view we're pointing at. You can break that, but it's a pragmatic compromise because Rust is Rust. So for now, that's what we're doing. And the views just hold a tile shader and a tile view each, which are still just the same tile shader that I showed and the same tile view that I showed in OpenGL mode, and something similar in Vulkan. Probably, I don't know yet, because we don't have that yet. So that's what that has. How do we use that? Well, it's quite similar. We ask for a new single, which is just a convenience function that means give me a new scroll manager with a single viewport. We also have one for quad. I'll probably merge that to one where you get to specify the grid and it figures that out for you. But for now, we just have these two hard-coded ones. So new scroll manager with a single viewport, please. With this context, this width, this height, this scaling, and this default tile size once again, same as the tile manager. And then we have to set up the shader because that can vary by the view. So we have to create that. And this is actually used internally by the tile manager as well. That's why it's in the tiles crate. We just give it the context, the two shader files, and the view matrix, and it sets up everything else for us and gives us the struct. Then we add a view, because we don't have one by default, with this shader. We set the scroll manager to display this view, and then we have to add things to the view because it's empty. So we want to add our tileset like before to this view. We have to specify that. And the viewport is just used for that check that, do we have enough tiles in the vertex buffer, or do we need to make it bigger? And this is just which viewport to use. Now, when they're all the same size, as in these cases I'm showing today, we don't have to worry too much about that. But it may, if we do something fancy with like resizable windows inside the window for like a map editor or something, that may become relevant. So I decided to make it something you explicitly specify rather than just assuming 0. That way I can make sure I do that correctly depending on what I'm doing. And then we add our tile map. And once again, we specify what view we add it to, and these parameters like before. Oh, and so are these ones. And then we set the scrolling, just like the case above, except we have to specify that we're setting the scrolling for viewport 0 specifically. This is like before, this is like before, this is like before. And we tell the scroll manager we'd like to scroll viewport 0 by this same amount. And then we just clear and tell the scroll manager to render. And that's our rendering done. The scroll manager handles all of it. And then this is all like before, and then we just need to delete the shader we created. Now, we could do that implicitly because the scroll manager will try to clean up any orphan shaders left inside it when it drops. So as long as this drops after, we could just not clone here, or you could scope it by putting everything inside a function or something. But I decided to go for the simple approach, which is to just have a delete function that deletes it and just call that. So that's what we're doing. And that brings us to mode 2, finally, the split screen, which let's remind ourselves what that looked like quickly. We have 4 views. They can all scroll, or viewports rather. They can all scroll with different keys. And this code is going to look a bit deja vu. It's very similar, but let's go over it quickly. Where's 2? There's 2. We again have a scroll manager, but instead of saying new single, we say new quad, which means give me a new scroll manager with a quad split screen setup. So 2 by 2 basically. We create the shader like before. We add the view like before. We have 4 viewports, so we set all 4 to show that view. We have the tileset and tilemap like before. We have 4 viewports we want to scroll to that nice center position, so we have to scroll those, all 4 of them. This is like before, except we have 4 deltas now, because we have 4 viewports, so we have to set all 4 deltas to 0 and take in 4 sets of inputs, arrow keys, WSAD, HKUJ, and numpad. And then we have to scroll each one by its respective deltas. And then we clear and render, and that's it. And the rest is basically the same. And that's about all I got this time. See you again next time, and I hopefully have some cool sprite stuff going, and hopefully that won't take 2 months too. Bye.